All right, this is Professor Denholtz, continuing with Lab 3, Problem 2. So I am going to do some calculations on screen. I think that might be a little bit easier to follow. Um, but okay, so let's go ahead. You know what, I actually will start. I'll just start over here. And so we could see that at this corner, we could go down by 0.48. So we can look at this edge. Because it's straight lines, we know that this length is going to be the same as this length. So I will start by going down by 0.48 and then zooming in considerably to where I am. And so then we want to draw a straight line from here to here. And it looks like that everything is really measured from this point where the rounding sort of begins. So the total length is 4.7, but we're going to want to subtract 1.4 and 0.52, and that's going to take us over here. So 4.7 minus 1.4 minus 0.52, and looks like we want to move to the right by 2.78. And then, let's see. So the total length is 1.42 from the top edge to the bottom edge. And we know that there's this gap of 0.6, actually, no, sorry, we want to look at this side. So we know that the total length is 1.42. And we know that this is 0.48. And there doesn't seem to be any information given as to if this is put right in the middle, the vertical middle. And because there isn't, I'm going to go on the limb and say it is in the vertical middle. If not, they would have dimensioned somewhere else. So it's going to be 1.42 minus 0.48 divided by 2 is how far we're going to go down. So let's take a look at that equation. So 1.42 minus 0.48. Oops, I typed that in wrong. So 1.42 minus 0.48 divided by 2 is 0.47. So we're going to be going downwards by 0.47. And then we could see we're going to the right by 0.52 and then 1.4. So let's type those in. So 0.52 and then 1.4. And now we're basically at the corner where it becomes a rounded edge. And so we know what we would see. We would see the length of the radius. And so the radius here is 1. And so we're going to come out by an additional 1. And if this isn't clear, it will be demonstrated in class what I mean by that for it to be a little bit more clear. Basically, if you're looking at the front of this, the orthographic view, you wouldn't see the curvature from the front view. You would see the curvature of this radius at the top view. So it would appear to be a rectangle from this view. And so that's what I'm trying to explain here. And so basically where we started here, so at this point, this is where the curvature began, and this is the end of the curvature. So this is the leftmost blue dot there, and then we would see the radius, you know, about here, which comes out to here, over here. And this looks like it's going to be symmetric to me, but let's confirm. 1.42 minus 0.64 minus 0.39 is how much we're going to go vertically upwards. But so let's just confirm that. So 1.42 minus 0.64 minus 0.39, and it is equal to 0.39. So it is symmetric here. So we'll go up by 0.39. Then we're going to be going in the radius of 1. So we're going in by the amount of the radius, so 1. And then we're going to be, that brings us to this point over here. We're going to go in by another 1.4 and then up by 0.64. And then we're going to come out to exactly where this point is. So now we could go over by 1.4. Then we're going to go up by 0.64. And then we're going to come out to this point. We're going to go up by 0.39. And we're going to come out to this point. Then, actually don't remember off the top of my head what we made this length, but whatever length we made this, we're going to be going down by that again. So that's going to be 1.42. So the total length minus 0.48 divided by 2. What did I get rid of my calculator? All right, so 1.42 minus 0.48 divided by 2 is 0.47. So now we're going to go down by 0.47. We should be able to just horizontally connect here. Yep, 2.78, that sounds right. So this is in fact a drawing of the front view. And now based on this, I'm going to draw some fold lines in. So these are just going to separate our different lines. And here you have to decide if you want to do the left side view or the front side view. I'm going to do the left side view. Now this may not necessarily be the easiest view. This is just the one that I happen to be drawing. But recall that I am not going to draw in all the hidden lines, center lines, and there might even be some solid lines that I don't draw. And so I'm leaving that part for you to do individually. So you might want to say, you know what, I'm going to do the right side view instead, or stick with the left side view, but it's going to come down to, it will impact how to complete your drawing. So I'm going to do the left side view, so I'm going to draw a line that goes a little bit further out to the left. And then this. And so the next thing I'm going to want to do is I'm going to want to draw the top. So I'm going to want to switch to projection lines over here. And I'm going to draw a few projection lines coming upwards. So this is going to show where the endpoints should be on the top view. And it was pretty handy that I had the 1.4 here because that's going to show me exactly where the curvature begins on the top view. So I should be able to snap to that, I believe, over here. And what else do we want to show? We could put a projection line up here because there should be a solid line over here. You'd be able to see that, but I'm not going to draw that in. All right, so what's a good way to figure out what this length is? So we can see that it's 1 unit to the circle, and it's probably symmetric. That could be the case. So if it's symmetric, that means this length would be 2. But there's a more factual way to determine it. We can actually take a look at the radius over here. The radius is the location of the center to the end of a circle, and this radius is 1. That means the distance from this center to this edge is 1, which is the same as this distance to this center, this distance to this center, this center to this distance, this center to this distance. Well, the center over here to this distance is 1, and the center over here to this distance is 1, which means the total thickness across is 2. So we, in fact, were correct that this circle is right in the middle. So we want to draw a line that has a thickness, a length of 2. And so that's what I'm going to do over here. So we want to go up by 2. And we should be able to go all the way across to this projection line, 4.7. That's correct, we could see that over here that this is 4.7. And second one should be also 4.7. So I'll just type it in also this time just to show that it in fact does go to that projection line. And here we want to have an arc. So we have a start, an endpoint, and a radius. Let's see if that's enough. So we have start and radius. That sounds pretty good. So we will start over here. We can end over here. And we can use a radius they give us of 1. So I'm going to type in 1. And there we go. That is exactly what we wanted to see over here. And so this is the top part of the drawing. Now, mind you, you still need to include a circular hole here. You actually have to include multiple holes. I am going to touch on this one at the end of the video and describe what this means. But we also have to have circular holes over here. There should also be many hidden and center lines on both of these. And there should also be a solid line over here. So you would see that solid line on the top view. So you do have to draw that in as well. Now, before I get to sort of the ending stuff, we still have to do a side view. And a side view, I'm doing the left view, as I said. So let's put in a few projection lines. So I'm going to switch my layer back to projection. And I'm going to draw a few of these over here. You want to get it from all the main visible parts. And so we already discussed that we know this going across is 2. We know this is going across 2, and we get all that information from the radius. And so what we're going to do is we're going to draw across by 2, and then we're going to connect the projection lines. So let's go 2, and then up, and then 2 across again, and then right back down. And so these are all of the external lines. Now, I'm going to give you a few tips. So here, where we can see this, so this is if we were looking at this coming into the front view from the right, that's where we would see the left side of this. Now, there are some lines you would have to draw. So you would have to draw solid lines over here where you could see this edge, but you also need to draw solid lines where you could see this edge. Now, don't forget, this edge does not line up with this edge, which means over here in our side view, you're going to have hidden lines for this edge, hidden lines for this edge. You're also going to have hidden lines from this cut over here, hidden lines from this cut, and this through hole cut as well. Now on the top view, you're going to have over here a solid line, so I will draw that one in because that's right where the projection line goes. You have to draw in the through hole over here, and this is a counter bore. I am going to discuss that in just a second. You have to draw that counter bore as well. And over here, you have to draw hidden lines to show these circular holes, because we would see straight lines on the front view for both of these parts. There would also be the counter bore you'd be able to see over here. And all of those need hidden lines, and they also need center lines. So make sure to include all of them. And so I'm not going to go into any more detail with actually doing the drawing for you. This is one where you really need to try doing it yourself. I think the hardest part is coming up with going from isometric to orthographic. Now, just the last part is knowing where to add in the hidden lines and the center lines. If you are having trouble go back to the orthographic view slides, the first week, the slides 1 in the orthographic weeks folder, because that's going to show you exactly what to prioritize with hidden and center lines in relation to solid lines. Now, the last thing is I wanted to say what this is. So this is a counterbore. It's used with this symbol here that's kind of like a rectangle with one length missing. It has a little bit of a U shape. It says 0.65, counterbore 0.90, and then there's this line with this arrow going down 2.4. I'm sorry, 0.24. It should be. And so it's hard to see, but it should be 0.24 over here, and this is a 9, not an 8. And what this is telling us is that the diameter switches. So a counterbore, this is in, I put it in here, I called it helper, lab 3 helper image. This is what a counterbore looks like through a cross section. And we would see that counterbore on the cross section. So you would draw something that looks like this around here where there's the counterbore. So where we see this stuff, it's over here. So that's this location. And so you're going to draw something that looks like this. It has kind of a T-like shape. Now the only thing is this image here, this helper image, is reversed. So it would actually have the longer part on the bottom and the more narrow part on top. So it would look like an upside down capital T is basically the shape that you'll be drawing. And what this is telling us is that the diameter starts at being 0.65, and then at a depth of 0.24 switches to being a diameter of 0.9. So you know what? Maybe I'll just put this one part in just quickly for a little bit of clarification. So I'm just gonna. I will draw this part, but I'm not going to draw the rest of the hidden lines. So if we have, let's see, our circle's measured at 2.3 from this corner. So I want 2.3. Oh, I'm sorry, it's from the back corner, so I measured that from the wrong spot. So it would be from over here. We want a line that's 2.3 in length. And so this kind of shows us where the center of this hole is. And so now I'm just going to draw another one to sort of locate it. You know what? Actually, let me undo that. So this is also going to give me a starting point where I'll be able to snap to the midpoint because I made a separate connection. So these are two different distinct lines. So now I can snap to the midpoint over here. And so basically, we start out with a diameter of 0.65, and then we go to a diameter of 0.9 at a depth of 0.24. And so over here, we would see the concentric circles over here, but I'm not going to draw them. I'm just going to draw the counterbore on the front view, but you do have to draw the counterbore on the top view. And it's actually a little bit easier to draw this if you draw the concentric circles first, but I just want you to understand what the shape looks like. And so I probably would recommend drawing the concentric circles over here first, and then moving on to the lines over here. But let's have a few more. Oh, I know, I'm on the construction layer. So to do this, I'm going to want to do half of 0.65. So let's just see what that looks like. 0.65 times 0.5. So we're going to go over by 0.325. So 0.325. And we do that in both directions. And from here, we're going to go 0.45 in both directions because 0.45 times 2 is equal to 0.9. So 0.45 and 0.45. So initially we would have a diameter that goes from here to here, and then at the depth of 0.24, it's going to switch to a diameter that looks like this. And so because the depth of 0.24 is half of 0.48, it's going to occur exactly at the midpoint. And so that's why I wanted to make sure I could draw a midpoint over here. So these are just going to help me do some quick drawings of the counter bore. And let's switch to our solid layer. And so that's what your counter bore will look like on the front view. Again, I would probably start with the concentric circles over here and then draw the projection lines downwards. But it should look something like this. And so if I hide these layers, when you're submitting, you should have something that looks like this, except recall that you need to finish the solid lines over here. You need to finish all of the hidden lines and the center line, so I have not included any. It's your job to figure out exactly how to do that based on this drawing. Again, if you're stuck, refer to the slides from orthographic view, slides 1 in the orthographic views folder.